Hi, welcome to part 12 of the video series about the work and energy. In the previous two videos, we have solved some examples to see the work-energy theorem in action. In this video, we are going to learn about conservative and non-conservative forces. In the topic of laws of motion, we learned that we can split the forces into contact forces and non-contact or field forces. We can also categorize the forces as conservative or non-conservative forces. A force for which the work done in moving an object between 2 points is independent of the path taken is called conservative force. It's also worth noting that conservative forces do not dissipate energy, and the total mechanical energy of an object remains constant if it is only acted upon by conservative forces. Elastic force, electrostatic force, magnetic force, and nuclear force are some examples of conservative forces. The conservative force with which we will deal most in this topic is force of gravity. Let's imagine three identical objects. All of them are at the same height from the ground. First object is released from this height and drops to the ground. Second object, which is thrown upwards with an initial velocity, moves up for a while and then drops to the ground as well. Once released, the third and the last object slides down the incline and reaches the ground. We can observe that the heights all three fall are same. As we recall from part 4 of this video series, work done by gravity on these objects can be calculated as force of gravity multiplied by the height objects dropped and cosine 0. We use 0 as an angle as direction of force of gravity and vertical displacement of the objects are same, both points downwards. Objects are identical, meaning their masses, and consecutively the forces of gravity applied on them are same. All three dropped from the same height. As a result, we can say that works done by gravity on all three objects are same, even though their trajectories or paths were different. Therefore, force of gravity is a conservative force. By reversing the process and doing exactly the same amount of work against the force of gravity, we can regain potential energy of these objects. Opposing to conservative forces, work done by non-conservative force is path dependent. These forces do dissipate energy, meaning the total mechanical energy of an object will change if it is acted upon by non-conservative force. Examples of non-conservative forces are friction force, air resistance, tension force, or any other external force like force of engine. Let's imagine an object and three different paths it can take from the beginning point on the left to the final point on the right of the diagram. While moving from one point to another, the object will experience a friction force at each point of the path. Due to friction, some of its kinetic energy will change to heat energy. As the paths on the top and bottom are longer than the one in the middle, more energy will be dissipated. Hence, the work done by friction on these two paths will be more than the work done on the middle one. This means that work done by friction force is dependent on the path of the object. Thus, friction force is a non-conservative force. In this video, we learned about conservative and non-conservative forces. In the next video, we are going to learn how to calculate work done by non-conservative forces. Thanks for watching. Don't forget to subscribe and turn on notifications in order to be updated about the new videos.